Hey everyone. So what we're going to do in this video is we're going to go over your slope-intercept form notes. This is a continuation of your slope lesson. You guys practice doing just finding slope, understanding what it is, and when it talks about straight lines. So we're going to talk a little bit more in depth about slope-intercept form, which is basically like a mathematical equation that gets you to understand what a straight line is doing when it comes to a graph. Okay? So just follow along the notes. I'm going to go with you, and hopefully at the end of this will make sense. So when I draw a straight line, that straight line always has a road map, okay? And that road map is based off of two specific factors that you will always be looking for these straight lines, okay? So the first one of those is what is the slope, okay? Again, the slope is the numerical value that describes how a line travels from point to point. And we know it as the change in y, again, your up and down or your rise of the line, compared to how it's moving side to side, which is the change in x or your run. Okay, so it's always that fraction. Again, sometimes we write it as a whole number because it's over 1, but it's always usually starting as a fraction. Okay, so we practice finding the slope. That should be pretty easy to find. What we're going to do next is add in one thing, and this thing is called the y-intercept. The y-intercept is that if I have a line that is traveling, I'm going to find where that line crosses over the y-axis, again, the up and down axis. So I'm going to find the spot that it crosses over the y-axis, and I'm going to identify that coordinate. That coordinate will always appear as 0, comma, and then whatever number you cross over. Again, the 0 will always be there because we talk about graphing. You start in your origin, and then when you start graphing, say we're going to graph 0, comma 3. 0 means we move no left or right spots from the origin, and then we just go up to the third spot, and that would be the coordinate. Okay, so again, the y-intercept is always just going to be the y value off of that coordinate. So what we're going to do is take those two pieces of information from a line, and we're going to write a mathematical statement from it. Okay, so using this example, let me get those two pieces of information from the graph. The first thing I want to get is that slope. So the slope on this line is telling me that I'm moving up 2 spots and forward 1 spot. So I take that information up 2, forward 1, and I make it into the fraction of rise over run, 2 over 1, which gives me a slope of 2. So I know that the slope of this graph is 2. So then I'm going to find that other piece, that new piece of information, that is the y-intercept. So the y-intercept is where I'm hitting the y-axis. And as you can see on that graph right there, that's where I hit the y-axis. That coordinate is at 0, -1. So that means I'm going to take the -1 part of that coordinate, because the first part will always be 0, and that's going to be my y-intercept. And what I do is I take those two pieces of information and I create what is known as the slope-intercept form equation. So as you can see, it's the setup right there, y equals mx plus b. Now don't worry about why they're using m and b. It doesn't make sense based on what they're talking about, but that's what is always used, so that's what you just have to accept it is. And so the m, which is that multiplier on the x, is representing your number for your slope, and the b is representing the intercept value. So I just plug them in. So the slope of 2 goes right here, and the y-intercept of -1 goes right there. And I get an equation for the line, which again is known as slope-intercept form. And that equation is my roadmap of determining what my line is doing on a graph. Okay, all straight lines, with one exception, which is the vertical line, which we'll talk about at the end, all straight lines will have some combination of a slope and y-intercept that tell you how it's traveling. Okay, so that's what you find to create it. Now, a cool thing about this, if you want to flip over to the next page, a cool thing about this is once I have my equation of a line, I can find any coordinate off of that line and mathematically test it in the equation to see if it works. All right, so what I'm doing is I'm taking the top, back on your example on the first page, I'm taking that top coordinate. That top coordinate is at 3, 5. So what I'm going to do is I'm going to take that coordinate, which is an x and y value. I'm going to take that and I'm going to use my equation to test that coordinate to see, does it actually fall on the line without using a visual. All right, so again, I take my equation, slope of 2, intercept of -1, so y equals 2x minus 1. And I'm just going to do a simple substitution. I'm going to take the x value from that coordinate I chose. I'm going to plug it in for x. I'm going to take the y value I chose for y. I'm going to plug it in there. And so I get this mathematical statement right here. And we're just going to work through it. If 5 equals 2 times 3 is 6, and then 6 minus 1. Well, 6 minus 1, 5 equals 5. That works. That's telling me that the coordinate I chose sits on the line that is being described with this equation, that slope and that y-intercept. Okay? And it doesn't, I can be any coordinate. So let me go back for a second. Let's just test a different coordinate really quickly. Let's choose this coordinate right down there, the bottom one. So that bottom coordinate, that position is at -2, -5. So I'm going to take my equation for this line, the slope of 2 and the y-intercept of -1. I'm going to plug in that coordinate's value. So the y was -5, the x is -2. And so now I have this mathematical statement. So I have -5 equals 2 times -2, which is 4, or sorry, -4. And then -4 minus 1, I get also -5. And I showed that that mathematical statement is true. Okay? Now, just to show this really quickly, again, using the equation for this line, what if I chose a coordinate that is off the line? So let's just choose an easy one off the line, and let's choose this one right there. That coordinate is at 3, 1. Okay, so let's plug that into our problem. So y value of 1 equals the slope times the x value of 3 minus 1. So I get 1 equals 6 minus 1. Sorry. Was foreshadowing there. 6 minus 1, 1 equals 5. That is mathematically false. So because I chose a coordinate off the line, it doesn't work with the equation of the slope and intercept from that line. It does not work. Okay, but if I would have chose any coordinate on that line, it would have worked like the last two did. Okay, so that's a cool way that you can test that to see if it works. Okay, so just to show you another example using a different line, this line is going down. So again, the first thing we're going to do is we're going to find that slope. So the slope is showing us we go down 3 spots and we go forward 1 spot. So I take that, rise over run, I put it -3 over 1, and I get a slope of -3. All right, so the next thing I do is I go find that y-intercept. So that y-intercept part is where I cross the x-axis, and I'm crossing right there on that coordinate, which is 0, -2. So I use the y value from that coordinate of -2, and now I have the two pieces of information, so I plug them into my slope and the y-intercept part of the equation, and that the equation for that line is -3x minus 2. And again, you could do a quick test. So say we choose this coordinate right here. That coordinate is at -1, 1. So I'm going to take my equation. The y value from the coordinate is 1. The x value is -1. So 1 equals -3 times -1 is 3, minus 2, 1 equals 1. It works, it checks out. So that's, again, where you can test it. Okay? So all of that has been having you take a graph and create, using the slope and y-intercept information, create an equation from that. Well, what if we wanted to do the opposite? What if we wanted to take an equation and create a graph from that? So we're going to think of the same idea. We're just going to go a little bit backwards. So again, using your setup, y equals mx plus b, m being the slope, b being the y-intercept, I identify those pieces of information from my equation. So there's the slope, that is the multiplier. So I know that slope being -2, that means I'm going to do the motion or movement of going down 2 and forward 1 spot. Then I find the y-intercept. The y-intercept is a +3. Oh, no, different color? The y-intercept is +3, so that means that's where I'm going to hit the y-axis. Now, the order in which you use these things do matter, because slope is a movement, but you need to know where you're moving from. So what you're going to do is, the first thing you're going to do is you're going to graph the y-intercept coordinate. So the y-intercept coordinate was at 0, 3. So I graph that coordinate first. Then I start using my slope. So my slope here was down 2, forward 1. So then I use the y-intercept and I start moving. Down 2, forward 1. Down 2, forward 1. Down 2, forward 1. And I make new coordinates. Now, in case you're curious, I was going one specific direction. So if my slope is telling me to go down 2, forward 1, I could actually reverse both movements up to backwards 1. And then I could keep the slope going the other direction. Again, up to backwards 1, there's another dot. Up to backwards 1, there's another dot. And you see those two dots fall in line. So sometimes you can reverse the slope to make more coordinates for your line. and then all you do is connect the coordinates you've made, and you should be making a straight line from that equation. Okay, so that's how you can take an equation and then create the graph, which is backwards from what you first learned. All right, flip over to page 3. A few things to wrap up. All right, this is kind of a big one. If you are looking for the slope and the y-intercept, there is one thing that has to happen in the equation, and that is that the y variable has to be completely isolated. If I could spell, there we go. It's got to be completely isolated. So if you do not have y by itself, there is no way you're getting the slope or the y-intercept. So that means you may need to do some shuffling. So take this equation we have right here, 4x minus 2y equals 12. I clearly do not have y equals, so I need to accomplish that. So what I need to do is I'm going to first move that 4x over to the other side. Again, cancels it over here, leaving me with the negative 2y, and now the other side, again, can't group these because they're not common terms, so I just write negative 4x plus 12. Then I get this negative 2 multiplier off y by dividing each side by negative 2, and I got to divide everything by negative 2. Cancels out the negative 2. Y is now by itself, so then I figure out each one. Negative 4 divided by negative 2 is 2. 12 divided by negative 2 is negative 6. And now that y is by itself, now I can get the slope and the y-intercept of my line, and then again I could go make a graph once I have that information. So make sure you understand you have to have this in order to get the slope and y-intercept. Okay? All right, and then the last thing, a couple special scenarios. Horizontal lines. Y'all learned in your previous lesson, horizontal lines always have a slope of 0 because anytime you have 0 rise and some run, 0 divided by anything will always be 0. So the slope of horizontal lines will always be a slope of 0. So if you take that information and plug it into a slope-intercept equation, the slope being 0 means you're going to have 0x every time. Well, if you have 0x, it's kind of like that part of the problem then doesn't exist. So when you see a horizontal line equation, you're typically going to see it like this, where you're just going to have y equaling the y-intercept number, and that's all you're going to see. It doesn't mean that the slope isn't there. It just means that the slope is 0 because it doesn't have any value there. Okay, so that's something to get used to when you see the horizontal lines. It doesn't mean that this equation is wrong, but you're just going to see typically written like this. Okay, now the vertical lines are the weird one. The vertical lines are the ones that had the undefined slope. Well, if you can't have a slope, guess what you can't have? You can't have y equals mx plus b because that thing right there just cannot exist. It doesn't mean it's 0. It just means it can't exist. Okay? Because if I take that off and just write this, I still have a slope if there's an x because I can have a 1 in front of it. So that means there's a slope. And if it's undefined, it can't have a slope. So what we can't do is we can't write y equals mx plus b for a vertical line. It will not work. So a vertical line has its own unique equation, which is just x equals a number. And that number is the x-intercept. So if you imagine a graph, and then you've got a vertical line going through right here, and say it's going through the x value of 3, that means you're going to write the equation for that line to be x equals 3, and that's what the equation for that vertical line would look like. Again, it's going to be unique and different because vertical lines are the only ones that do not have a number for slope, so that's why their equation is a little bit different. Okay? So, using that information, you have some practice you're going to go through about using slope-intercept and all the different parts of it, and you can use your notes to obviously go back, but I hope this video explained things well enough that you guys can understand what's going on with your notes.